Arduinos. We had a session earlier with Steve on the pad one, which was a lot more around coding. So this session is really just the basics. So it's how to get started with these wonderful little boards, what they actually do, and really just kind of get everybody to a point where they feel comfortable plugging them in, loading a few libraries, and start getting them up and running and working. I'm going to try. As I said on the previous ones, I want to try and make them a little bit more practical than just slideware. So we're going to attempt little cameras, because unfortunately Arduinos and servos are tiny, so it's going to be quite boring for you there. So fingers crossed all of this all works. So covering through Arduino, just the real basics of it. What does it do? How do we power it? What the inputs and outputs are, and what the different sort of definitions. Really just give us a sort of an overview. We'll get into a little bit of technical stuff, which is the serial and the I2 bus. But what I don't want to do is kind of go into too much detail, so really just kind of skim over. We'll then move on to the practical bit where we'll sort of look at the software. The IDE is the sorry, and then software encoding, which is looking at installing software, installing libraries, and then we're going to stick some servos onto it. We'll try and get them moving a little bit, and then what I'll do is I'll just show you one of the libraries that we've got that moves the DOA, and then also kind of what you've got for expanding. So the Arduino. It's really interesting. I went over to Italy recently to have a look at I met one of I think he was the CEO of Arduino, who was kind of talking about their strategy. And their strategy, he kind of did this presentation in a big corporate place, and he stood up and said, we haven't got any salespeople. He said, we said we don't protect our IP, we share everything, and we make this amount of money, and we've got this amount of customers. It's a really interesting business model because it's the opposite of what a lot of organisations do today, which is to build things, protect things, and then try and sell them. So I mean, it's really the open source model. So what Arduino is it's a completely open sourced microcontroller that is really focused on inputs and outputs. So whereas like the Raspberry Pis and these kind of things are true computers and they've got operating systems and you can run things on top of them, these are really focused on taking information from the real world, doing something with it, and then kicking it out so it starts to move other things. So for us in droid building or for just generally playing around with automation, they are exceptional. I'll touch on where they're going in as a company in the future, and it's quite really exciting as we go through that. So as it says there, I'm not going to read through it, but effectively it's an open source hardware family that allows us to connect pretty much unlimited peripherals. The other great thing with Arduinos, and again what their view is that we will sell branded Arduino boards and we'll make money out of it, but we're quite happy with the grey imports and Chinese clones. So if you're starting out, by all means, get onto eBay, buy a load of cheap ones. If you're going to blow the cheap ones up, and then you can kind of move on to some of the branded stuff. There's some of the high quality, more robust stuff like Adafruit, we do some of the peripherals, and then literally you can bang onto eBay and get IMUs and all sorts of things at about £2-3. So it's really cheap to get hold of. I would say that there's two approaches really, which is we can go down the pad-on route where you get a bunch of hardware, you connect it together exactly as the instructions say, you load the code, you cross your fingers, you hit go, and hopefully it wakes up, whistles and starts spinning around. If it doesn't happen, that's where you start to have problems. The other approach, which I kind of really recommend, is just play with the damn things. Get hold of an Arduino, get hold of a USB cable, a couple of LEDs, a servo, and just see if you can get things moving and you can get it to do things, because then you start to understand the basic mechanisms and how they work, which really helps out when you want to start to fault find in the future. The family of Arduino is massive. I've got a few up there, the Uno, the Mega, the LilyPad, the Arduino BT, the Nano, the Mini. Adafruit are doing these feather boards, they're called now, which are kind of Arduinos. See, Arduino makes hardware, but they've got things like inbuilt Bluetooth and inbuilt Wi-Fi. So really, there's a whole kind of raft of options. The one that I would recommend starting with is the Uno. That really is the kind of basic model, and it'll get you very, very familiar. The difference between all of these really is the number of inputs and outputs, and to some degree the processor that's on there. If you're interested in the technical stuff, if you hit the Arduino website, you should break down all of them. But there's a whole bunch of these. The great thing is the coding is the same, and the mechanism is exactly the same on the way that you use them. So I'll touch on the architecture of these things. You've got a fairly simple board. At the heart of it is this Apple microcontroller. That's the brains of it. But you've got some key bits. You've got a USB port. It uses the kind of square USB connection on there. And what it does is that provides the communication and the power for the Arduino if you're choosing to power it by the USB port. You've got a separate power input, and I'll go through the running them on power, but that's just a barrel connector that will run on 9 volts to 12 volts, so you've got a number of options to regulate, so they'll move that down to 5 volts. You've got a block here which is your power supply, so this is both input power supply and output power supply, so there's a VIN, which is a voltage in connector. There's a couple of grounds, there's a couple of 5 volts, and there's a 3 volt. I would say you really wouldn't recommend running anything off the Arduino power supply because the ampage that it can cope with is very, very, very small. But playing about for running a couple of servos, for doing some LEDs for a bit of fun, and by all means run it off the inbuilt power. But if you're going to start to construct larger models, look at powering the LEDs and the servos separately to the actual board, if that makes sense. And then you've got analog inputs, and you've got your digital inputs, outputs at the top. And again, we'll cover them in a bit more detail. There's a little connector there which allows you direct connection to serial programming, and that pretty much is it. If we look at the Mega, which is a bigger board, it just has more of these pins. The digital output, there's some of them, and if you just look at them funny little marks on the pins that are on 3, 5, 7, 9, 10, 11, they are PWMs. Stands for pulse width modulation. We'll go through what that means in a little bit more detail in a sec. The other thing that you've got on your inputs and outputs is 0 and 1 is a special one because that's your transmit and receive. So that's a serial connection. On the Arduino, the USB port, when you're actually programming in and out, is running by a serial. And you've only got one serial port, so you use either this or this. And it's quite important that if you connect anything via that serial port, and typically you might be running a Bluetooth module on there, as soon as you connect something via the Bluetooth port here, which is using these serial ones, it will corrupt any downloads that you're trying to do if you're trying to update firmware. So whenever you're trying to connect anything on USB, you're trying to download some new sketches and things like that, make sure that you disconnect pin 0 and 1. On the Megas and on some of the other boards, they have multiple serial ones, so you've actually got a dedicated serial connection to the USB port, but on the Uno, it's something to watch out for. And what you really can do then is expand them as much as you like. So, I mean, you've probably seen the Dio kind of rolling around a little bit. This is running on just on an Uno in the body. The controller at the moment is running on a Mega, but I intend to just put one of the little small ones on there, kind of the Mega, the Nano, to run, so it'll fit right inside the handle. So, powering the Arduino. Arduinos are pretty bomb-proof. They're quite difficult to blow up. If you try really hard, they're fairly easy to blow up. But they are pretty robust. And by that I mean, you know, if you're flashing it, if you disconnect it, if you want to reflash and put new code on there, you can just pretty much play with it to your heart's content, and they generally they survive pretty well. However, the bits that they don't supply very well is on power. So when I built my first R2 with the pad one, I not quite, as you do, you get really excited, you put all your cables in, you don't necessarily tie them down properly, and I had a 12-volt cable that just gradually drifted across my Uno, to which gave me that lovely blue smoke, that nice smell that everybody, I'm sure, in this room can recognise. And then you've got to work out how many components you've fried and how expensive they are, which luckily for me was just a shield and the Mega. But yeah, power's the one way to do the damage. So inputs, you've got 5 volts on the USB. You don't need to worry about that much because every time you plug it into a PC or through an external USB connector, it will run at 5 volts. The Uno can run at 5 volts or 7 to 12 volts. So on the jack connection on here, that will take 7 volts to 12 volts DC, which is the little flat lines you'll see on power supplies. And then these two big connectors are replicated in the power area. So in here you've got VIN, which is voltage in. Voltage in can be 6 volts to 12 volts, or you can stick your 5 volts on there and 5 volts to ground to power that. So you've got lots and lots of options. Typically when you're playing around, you use the USB. When you then start to create something that's a bit more kind of integrated, I would typically run power in through these pins just because they're probably a little bit easier than the jacks. The Arduinos use connectors called DuPonts, D-U-P-O-N-T. What I would recommend is getting your head around and just practicing with crimping DuPonts. These connector packs are pretty cheap. The crimpers get a good, reasonable quality crimper, again pretty cheap, and then a shed load of servo cable or ribbon cable, and you can start to make any length and any configuration of cables. You can buy them pre-configured from Amazon, but what you end up with things like this is you end up kind of having to loop stuff around because it's too long, or trying to stretch it because it's too short. So getting your head around making cables up on DuPonts is quite easy. I've seen them around today, but one of the great tools that goes hand in hand with these, once you get of an age, I'm over 50 now, is the little things that go over the head with the little magnifying glasses. So if you wear one of them, it doesn't necessarily mean you're old, but it probably does mean that you're old. But there's no shame in that. So once you've got one, you never take it off. For painting, for making cables, even for getting the little pins and the little holes, they're absolutely superb. Take them off before you go to bed. But other than that, they're great. So a little bit on input and outputs. So the main ones you've got is the digital inputs and outputs. I think we all understand what digital is, it's on or off. You've got about 14 of those, and you can configure them as inputs, i.e. switches, they're recording what's happening outside in the world, or outputs, i.e. you're switching something on or off. The clever stuff, and the bit that's really useful, particularly when you start doing servos and things like that, is your PWMs. And PWM stands for pulse width modulation. Have a Google about it if you really want to go into the technical crap, but what it basically does is it alters the pulse width very, 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 very quickly. So as it's kind of, what you can do is you can write to a pin with a number between 0 and 1024, or 1023, whatever it is, and what it will actually do is it will effectively vary the on and the off very, 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 very quickly. So what that will do is it will give you, if you put a voltmeter on it, you'll sort of see a voltage between 0 and 5. It's a bit like a variable resistor really. I think Steve, you described it as pulsing your foot on the accelerator. It is on and off, but it's that quick that it actually can make things go faster or make things go slower. And really this is, I don't know, again, servos are very, very simple. You've got a power and a ground, which is controlling or literally giving you power to the motor. And then you've got a signal, and that signal, depending on whether that's 0 or whether that's 5 volts, will determine the angle of the servo. So if we're controlling servos through the Arduino, all we really need to do is write that number, PWM, and literally the servo will move. The third type of pin that you have on these and there's a special section at the bottom which is called analog in. It's literally inputs only, and it measures analog voltages coming in there. So if you're running variable resistors or anything like that, or light sensors, they're generally connected to your analog in. In the code, you have to define which of these you use, and you have to define whether they're inputs or outputs in the PWMs, in the case of the digital ones. But ultimately, between those, that really is the heart of the Arduino. So you're taking either information in, you're doing some clever coding around it, doing some logic, and then you're kicking stuff out. And the amount of things that you can do with that simple mechanism is quite impressive. Does that make sense? Excellent, brilliant. No questions so far? Everybody's still awake? Anybody need sugar? What sweets? You need sugar?
How can you determine the time it takes to turn?
On the servos, I'll get into that, yeah. So one of the challenges that we have is if we're trying to do smooth animation with servos, is literally you'd say, I want to go from there to there, and the servo goes as quick as it can do. So if you try to animate doors opening and arms coming out, sometimes that can be quite severe. Now there's a library, I'll use that as this demonstration. There's something called servo easing, where what it actually does is it sort of goes what you would do normal acceleration, so it starts slow, and then it speeds up, and then it slows down to the place where you want to get to. The way it does that is it's literally moving the servo on a number of steps across that. Now I'll use it as a demo. I've got the DO head, which is what I use servo smoothing, servo easing for the DO head. But it does depend a lot on the servos that you use. Some jitter more than others. There's all sorts of kind of things that go in there, but that's how it does actually smooth. Other than that, there's no real way of actually controlling. You can reduce the voltage that goes into the servo. So where the servo is powered between ground and voltage, you can start to turn that down. That will make it a little bit slower, but it will also make it a little bit weaker. So, you know, it's really just a kind of understanding the options you've got software-wise to ease the servos, and then tuning the voltage down to get smoothness. Pretty much what I've done on the other DO is I've got the voltage regulator and knocked it down to about 3.2 volts or whatever, so I get the head quite smooth. As you start to pay more money for things get a lot better. I've tried to keep everything quite low cost, but obviously once the models get released, people start to upgrade them with greater and better kind of options. The other couple of inputs and outputs, serial. Serial is really useful because you can connect one Arduino with another Arduino and you can get the two to talk to each other. Connection is really simple. You've got a transmit which goes to receive and receive that goes to transmit. If you're connecting two Arduinos via cables, you need to also give a ground connection so that because you obviously know with voltage, it understands the differential between one area and another area. If you haven't got a common ground, it'll get really confused. So on where this comes in, it really handy is when then you start to use serial over things like Bluetooth or whatever, because then you can start to create very simple remote controls. So that's on these, that's what I tend to use. I use two HCO5, which are little Bluetooth modules. I have one Bluetooth module that sits on a master, one that sits on a slave, and it can send information back and forth. And there's some Arduino libraries that make that very easy to do. And this is what I said about getting your head around it, because once you get your head around how these work, you can basically create any sort of remote control stuff very quickly. And you can have a lot of logic that sits in it. I mean, by all means, you know, I'm not dissing the kind of the traditional radio control stuff, because it's a lot of advantages, but for knocking things up quickly for the house and the playground, it's really useful to try and understand the serial connection. The other connection we have is the I2 bus, or the I2C. And what the I2C bus is, it's kind of a special serial bus, but what you can do is you can apply addresses to different boards. So literally, you can run two cables between boards, and you can start to create a daisy chain So where I've used this is I've had a 16-channel servo controller in the body that does all the animations, and then I've got a 16-channel servo controller in the dome, which then does the animations in the dome. I'll connect them together with power, 2 serial connectors and ground, so 4 cables. And what I've got is I've started today's chain. These on the Adafruit 16 servo boards, you can actually get theoretically up to 62 of those boards. So on one Arduino you can address 992 servos, I think. I don't think anybody's tried that, but that would be quite funky feel to do. And this is what I say, is it really is quite limitless once you start to understand how that goes. So that makes sense now? Cool, right. Loading the software, I'm going to demonstrate this because it's really hard. So you go to the website, you see the IDE software, you download it, you run it, it installs onto your PC. I'm using 1.8.9 at the moment, which is the latest version. Steve, you were saying you had some issues, didn't you, with that one? Had to go back because it's not communicating by
Yeah, it wasn't talking to the boards for some reason.
Yeah, so, but the older one does.
Yeah.
Yeah, I've not had any, I don't think I've had any issues, but you know, I think these things is quite common with software. If we do have the issue, just try to kind of roll it back a little bit. It's available for most operating systems. I run on Windows, so I have no idea how it runs on Macs or Linux, things like that. But what I'll do is I'll step through what it is. I'll show you what the interface looks like. I'll talk a little bit about libraries because that tends to be where people get a little bit unstuck and they're asked to install libraries. And then what we'll do is have a little bit of a play with this Arduino live, what possibly can go wrong, to see if we can get some kind of servos moving. So let's try that one. There we go. So this is the basic IDE, which is the development environment for Arduino. When you fire it up, you literally get this kind of empty space. And what we'll do is, I'll just take this USB cable, and honestly, if you've not played with them, just grab one, plug it in, and just see if you can break it without shorting the power out or making it smoke. We're just plugging things in. When you plug it in, you get your little flashing light, which means it's alive and it's doing something, which is fantastic. If you look closely, you can see past the brightness, and you've got your headset on. If you're over 50, you can see the transmit and the receive lights flashing away when data's going through there. But one of the things, first of all, is to make sure that the software knows which Arduino board is that you're actually using. If you click onto Tools and Board, you've got a whole bunch of options on there. The one that we've got at the moment is the Arduino Uno, but literally you can see all of the different versions that are available at the moment. And they are the ones that are built into the software. So if you were to get an Adafruit Baddeley or one of the newer ones that use the same approach, they'll come with their own configuration software and literally appear on there. So we'll stick with the Arduino Uno at the moment. The second thing, once you've selected the board, is to select the port. As soon as you plug the USB port into the device, the serial connection, it will come up as a COM port. Depending on the USB connection that you use and depending on the devices, the numbers will differ. But literally you select COM5, and at that stage now, the software on there is configured to start to talk to this little baby. To get started, the great things about Arduino is you do not need to be a programmer to use it. What most people do is they grab all of the example sketches and then just load them on and start to configure and tweak numbers within them, rather than sitting down and writing code. So when I first started doing this, I was literally just nicking stuff, copying chunks out of things, finding it didn't work and playing around with it. Really important bit, if you click on File and Examples, there is a ridiculous amount of code that's built in there, taking you really from the very, very basics, so blink without delay, and as you start to get different libraries in there, and libraries are pre-written routines that support different hardware or different functions. Most libraries, if not all libraries, come with their own examples. So there's a couple on the bottom there that I've added to play around with. So we've got the library. What I do now, what you do is add the library, click on the examples and load one up. I'll load link, which I think is the one that most people start with. The guys that write all the codes and the examples do far more work than what they need to do because they write all the instructions and other little notes in there, so that it makes it easier for you and I to do. So at the top there, so this isn't going to be a kind of coding area, but what this code does is it blinks the LED 1 second on and 1 second off. The other thing that they've done with Arduino is because they know that you don't necessarily want to buy an LED, they've built an LED in there so that you can play with the LEDs, so you don't need anything other than this if you want to flash LEDs. Flashing LEDs just get boring after a bit once you've got some stuff. So this one, just quickly, will first of all say I am going to use a pin called the LED built-in. It's an output, and this is a digital pin on or off. And literally what this does here is it writes the built-in LED as a high, it waits for a second, and then it writes as a low, and then it waits for a second. So surprise, surprise, it flashes an LED every second. Amazing. To get that sketch onto here, we click sketch and upload. And what happens when you upload is you'll see at the bottom it says compiling sketch. After compiling sketch, it should say uploading. After uploading, it should say done uploading. Under normal circumstances, live demonstrations, it comes a big error there and we have no idea what's going on with it this time, which is brilliant. And what that's actually doing now, as you can see, is that's flashing that LED on and off every 1 second, so that's that built-in one. And this is what I said about grabbing the built-in code and then saying, do you know what, I don't want it every 1 second, I'm going to put that to every 1/5 of a second and make it a little bit quicker. So just change those to 200, click on sketch and upload, and then what it's starting to do now is it's firing all of that data across, and then it's flashing that code, flashing that LED now a lot faster than what it did do previously. Once the code's on there, and what you've got here is you've kind of got, this is the raw code, this is what the programmers write, it's based on C++. If you've done any basic programming or any kind of coding whatsoever, you become quite familiar. There's loads of resources online for each of the different functions, but if you click on File and Examples, most of the functions are actually in there. So not just the hardware functions, but you can also start to look at different ways of whether it's logic and all sorts of programming that sits in the background. So really kind of, first of all, get a board, plug it in and start to play around with some of the basics. So you can, and then you've got all sorts on there, so you can start to fade LEDs, and rather than just flashing on and off, we start to decrease and increase the voltage slowly. That makes sense now? Hey, fantastic. Anybody need sugar? Okay. So that's really the first bit of the code. The second thing is the libraries. So if you fire any web browser up and we go, is that in the news? There's an air hostess that was drunk during a safety stop. If anybody wants to watch that. If you click on Arduino library for servo easing, for example, and then you find typically the GitHub, click on these, and then literally what you can do then is download the library. Libraries download in zip files, and all you've got to do once you've downloaded the library into your download folder is start to add that. So if you click on include library, add zip library, it's really as simple as that. So in the first instance you download the zip, you click on the add zip library, go into your downloads directory, and then you will find the whichever is the download file. So servo user master, servo user master. Make sure there's no dodgy downloads in there. Click on open, and it's it's telling me now that that library is already installed. That would then be the library installed on the Arduino, which means you can now use that particular section of code. That make sense? Yeah. Oh, great stuff. So what I'll do for the demonstration is we're now going to start to take the servo and we'll start to connect to servo. So you can kind of see these ones that we're using here are very small, very cheap SG90 servos. They're very lightweight. There's SG and MG. Technically the M's are metal gears and the S are the plastic gears. These are the ones that we're using. Now the end cables, just to make things awkward, the end cables are female and the end that we're plugging it into on the Arduino is female. So this is where they're asking you to buy things like this or to get some jumper cables. So I've made up a couple of cables here which are used just for testing and playing around with servos, which are male to male, if you can kind of see them. And on one end I've got a 3-pin, and on the other end I've got some kind of loose areas. So let's just hold up, let's fire up one of the example sketches. So example sketches, we're going to have a look at a servo example, shall we? And we'll have a look at sweep. So this is literally the stock one that comes with the Arduino, and it's a very, very simple bit of code. So the first thing it does is it includes a servo.h, that's a library. That's a bunch of code that's cleverly written that you don't need to worry about to make your life easier. We're including the servo library. It is now creating a servo object. It is making the position of that servo object 0, and then what it's going to do is it's going to attach that servo to pin 9. I know that because it's written in the code, so it makes it all really easy. So the first thing I want to do is take my cable. Now there's three pins on the cable. You kind of got a brown, you've got a red, and you've got a yellow or an orange. The brown is ground, and the red is the voltage that's needed, and then the yellow is the signal. So what I'm going to do here is I'm going to connect I've got my magnifying glasses, so bear with me if I get it in the wrong hole, so to speak. I'm going to connect that to ground. I'm going to connect that to 5 volts, and this one goes to, what pin was it?
9.
Huh? 5.
Fucking
9.
Pin 9, well done. Pin 9. You all failed. So I'm going to connect that up to pin 9, like that. And that's, so if you can see, I've got 2 connectors, which is my power, and I've got pin 9 on there. So that's that connection, and then what I'm going to do is make sure on the end connection that what we've got is we've got the signal to signal, power to power, ground to ground. So in theory, that should now be connected good and ready so we can move the servo. So we'll plug it in, fingers crossed and no blue smoke. Yeah, there we go. The sketch isn't on there, so the servo is stationary. So pin 9 is the one that controls that. What it's doing in the code is it's first of all going to write the position. There's kind of 3 sets to the code. This top set is a global set, and what that does is it's where you include all of your libraries and do things that affect everything within the Arduino. The second one is called setup. That's a piece of code that just runs once. And then the last one is a loop. And what the loop does is it literally runs from the top. When it gets down to the bottom, it zooms back again and it just continuously runs. So the loop is literally going to count from 0 to 180 degrees of the servo. It's going to increment it in ones, and then it's going to write that position to the servo, and then it's going to delay 15 milliseconds just to give the servo the chance to get there, and it's going to move it. Once it's done that sweep, it's then going to go in the opposite direction from 180 back to 1. So that's what the code does, and then it's going to repeat itself. So in theory, if everything works, this servo should just go back and forth. So if I click on Sketch and Upload, again checking tools, you can see it's the Arduino Uno comp, Sketch and Upload. It's now compiling Sketch. Once it's compiled Sketch, it's uploaded. Once it's uploaded, it's done uploading. When it's done uploading, we've now got that servo sweep. So we're moving the servo just with the stop on. If we wanted to increase the speed of that, we could put a delay of 1 in there, for example, just similar to what we did with the LED. Click on upload. Once it's uploaded, you can now see it's going. It's not even getting to the position it wants to because it's going that quick. So by fiddling around with this kind of code, you can start to do all sorts of different things. Sketch. Upload. Very excited. So that's with 6 milliseconds.
Can you also change like the degree? So you, instead of 180, you can do it like 140 or?
Yep. Yeah, so if I go back to the code and change that to from 180 just to 90, for example, and then I go from 90 back to 0, hit Sketch, upload. What we'll see is it then starts to move on 90 degrees. And if I want to slow it down even more, I could just do that to 50, for example. And what you do is get a very slow sweep. Load. You get a very slow sweep then as it starts to just move from 0 to 90 degrees and back again. And this is what I was kind of saying at the beginning, that if you start to play around with this, you start to get more confident. You can kind of see there, I'm just altering code, hitting upload.
Like on the Arduino boards.
Sorry?
I've got Arduino boards,
Yeah.
and they've got like 10 servos.
Yes.
So I do that 10 times
Yes.
for each servo.
You'll find if you look on this code, what you've got is you've got something, you've got the servo library is calling something my servo. My servo is that servo. If you've got another one on it, you'd have to call it something else. We'll call it your servo.
Yeah.
And then, you might have servo 1, 2, 3, 4, and 9. Lawrence's servo, so about 3 servos with different names. And then what you can actually do is start to look at the code and see duplication. So like my servo, your servo, Lawrence servo, they each need attaching to different pins. So if we wanted to, in fact, we can probably do that with, I'll show you that so when we start to connect the head up. So yeah, so you can actually connect the second, so now I've got a second servo. So if I connect the second servo, I'll just quickly show you how that works. Which connections are right. Let's get this, let's just connect it onto, this is where you start to run out of power connections on the board.
What's the range of a normal servo in terms of angle?
What's the range?
In terms of angle?
Just over 180 is normal, and we can get different ones, so you can get 360s and you can get continuous servos, but 180 is the normal one. 5 volts, and we'll put this one on, we'll put this on pin 10. So what I've done now is I've got 2 servos. There we go, I've now got 2 servos. The power cables are on this side, but they're all connected into power. And then on the other side, I've got one that goes into pin 9 and one that goes into pin 10. So now they're connected up. Click that in. So what I can do on the code is I'm now going to create another servo. So where it says servo, my servo, this is what I say about, you don't need to code, all you do is copy and paste. We'll call that your servo. The coding is case sensitive on Arduinos. Your servo, and then where it says attach on my servo, we're then going to click on your servo and attach that. And where it says 9, we want to attach that to pin 10. We're going to attach it to the other pin. Yeah. And then once you've done that, then where you've got the next step is my servo pos. Control C. And what I will do is then go, no, we won't do that. Yeah, so let's put space there, and there we go, and then I'm now going to do your servo, so that will now move into that position, and then what I'm going to do is put that code in, from 1 to speed, into there. So what I've done now is I've created my servo, your servo, I've got 2 servos on the board attached to the pins. If I click sketch and load, in theory, what should happen is we'll then now focus the camera on. And you can see there, you've then got the 2 servos working. If you wanted to, and they're both running in the same loop, so what I can't do is do different speeds or different directions for the servo, but obviously if you were coding, there's various bits of code you can do to just get the speed a little bit better. So, well, there you go. So then you can run to, and you can reference that independently within the code. Does that also make sense?
You mentioned earlier that you can just apply a full sway signal to the servo from 0 to 1024.
Yeah.
Is all the library doing here is converting that number into an angle? So if I didn't have to use the library, I was quite happy to put 0 to 1024 rather than 0 to 180.
Yeah, pretty much. You can control servers direct without using the library. You just write them to a PWM position, and it will pretty much do that. The servo library just makes it a little bit easier for you, really. If that makes sense. Cool. All that makes sense? Good. So what I'll do next is I'll just show you one of the other ones that controls servos, which is the servo easing. File examples. Let's go down there. So servo easing. So this is another library that's specifically there to control servos. If we look at it, it actually uses the servo library that we've seen already, and it uses something called the servo easing library. It's using the servo in pin 7, so what I'll do is I'll change that to pin 9, so I've got a servo attached to that. It's got some bits of clever code that you can play around with. And what servo easing does is, you can see the command just there. What it's actually doing is it's moving to the 90-degree position, but it's going to take 5 seconds to do that. So the 2 numbers are, where's it going and how long do you want it to take to get there? What servo easing does is it doesn't do that as a straight sweep. It does it as a slow speed up, so it's a lot more natural. So if you were building animatronics or you wanted something that created real-world animation, it's actually going to start doing this, and then it gets a little bit faster, and then as it gets close to this point, it'll slow down again. So servo easing as a library is brilliant if you want to do stop animation. The challenge you've got with animation in that kind of world is that it needs to know where you're going to go and how long it's going to take to get there before you actually make that movement. Which, if you think about it, exactly the same in real life. To know where that is, I will now move and then slow down and get there. But if you're linking it to a controller where it doesn't know how you're going and how far it is, it becomes a little bit of a challenge to try and get that to replicate. But for pre-programmed animations, things like doors opening, arms coming up, all the panels and things like that on R2, you can create a lot more natural kind of movements, if that sort of makes sense. So what this is going to do is it starts off here, and what that does is it'll just slowly center as a start position, and then what the code actually does is the first thing is it update. Update is a specific thing that writes to the servo to say, right, move to where you should be. It then has got an if statement, and it says, if the servo has arrived, what I'm going to do is choose a random angle and a random duration, and I'm going to move it somewhere else. And at this stage, it's now giving me a random angle between 0 and 180, so the full sweep of the servo, and the duration is between 200 milliseconds and 15 seconds. What we'll do is we'll take that down to 5 seconds, just so that we can, hopefully, if it chooses the 15 second one, we'll set as would. And then what it does is there's a couple of things here that will print it out to the screen if you've got a serial monitor attached, and then it actually moves that angle. Okay, so let's skip sketch, we can upload, same thing, compiling sketch, uploading, everything stops, done uploading. So what we should have now is after 5 seconds, we'll start to see movement on the servo, which is random. So if you watch it, it's kind of got slow down, speed up, slow down, speed up, slow down. So it's a lot more of a natural movement. Does that make sense? So that's the servo using library. You can use that to move things. You can move it on dials. There's all sorts of things you can do. It's a lot nicer movement. I think as you were asking how to slow them down, that's typically how we do that. So if I go on to typical Blue Peter style, one that we prepared earlier, if I click onto head movements, so I'll just talk you through what this is actually doing. So this is the I run this code pretty much just to give it some interesting animation on the DO head when it's pottering around, so I've not got to control it. But what it's really doing is it's connected 2 servos, one to pin 9, one to pin 10. It's defined 2 servo objects, servo 1 and servo 2. We call them my servo and your servo. Last time we called them something a little bit different here. And then we've created 2 servo ease objects, which is servo ease 1 and servo ease 2. It's got some clever stuff that it does on the setup, which we've seen previously. And then what it's actually doing here is it's now moving those 2 servos to random places independently between 30 and 150 degrees, which is the angle that I've used for it to the head to go this way, and between 60 and 120 degrees, which is the angle that I've used for the head this way. So this is just controlling 2 independent servos. I've got these already connected to pins 9 and 10, I think. So in theory, if I click on sketch and upload, what we'll do is we'll see how that servo easing works then on these things once it's uploading and done. So what we should see is we start to see different kind of random movements. And this is to really quickly add character to kind of any of the things that we build just by sticking a couple of servos in and getting them to move randomly. There's no real sort of magic to it. So voodoo. It's voodoo, yes, voodoo. So if I'll just connect this, I can't remember which is which, but we'll just we'll go with it, see what happens. I'll just connect these to the DO head. All I've got in the DO head is I've got a servo that turns the neck that way, and then there's another servo on top that turns the head that way. So it's literally there in that kind of a configuration just to do that. Put it in. And you'll see obviously giddy. It waits about 5 seconds, and then in theory it all starts to move around a little bit.
Looks scared.
Looks
scared.
There's a lot of people out there. Jesus Christ, where did you all come from? And I've ramped the speed up a little bit on this just so you can kind of see how it works. Does that all make sense?
Yeah.
Yeah? So,
How much do you have to buy of your own code in there, or is that all built into that?
that's pretty much cut paste, to be honest. It's as you kind of get as you start to play with the code, start to develop your own code, you can do logic statements and things like that. So, for example, where I've got this bar that moves back and forth, that's running off a controller, that's where you start writing your own code. But the code's fairly simple. So what you're doing is just talking about that one servo that is actually controlled back and forth. I wanted to control that off a pop, like the ones that you see in the amplifiers that turn the volume up and down. So I connected a pot to one of these Unos, and this is a very simple thing to do again if you wanted to play with it. You connect the output of the pot, which as you turn it around, it'll give between 0 and 5 volts in increments to an analog pin, and you record that. And what that does is it picks a number between 0 and 124. And then I'm assigning a variable, so that might be a 0 to 124 that understands where that pot is. And then I output that variable to a PWM that's connected to a servo. And as soon as I've done that, then I've got the control of the pot, which then controls that particular head. So from my perspective, what I tend to do is do as much as I can of putting and pasting, and then start to apply simple logic that sits between it. And then unfortunately what happens is you start to get brainwashed into programming, so you do start to think, I'll just write my own code. And then you think, oh my god, I've become a programmer, I've now got to wear sandals and t-shirts and stuff like that. So, you know, it does build up in increments, but I think the important thing to take away, I think, is that most of the code is written for you if you want to start adding that thing or details that's around there.
Mike, can you use servo easing with PWM?
Yes.
If you send if you do a send PWM mount servo, the servo can work there.
The servo easing only works with PWM pins. Right. So it literally does all the PWM stuff in the background. So on servo easing you have to use PWM connectors.
So you have to use the angle on that point.
Sorry?
You have to look at the angle on it, not the holes itself.
Yes, yeah, it does the angle. There is limitations on that particular version of servo easing if you're using the 16 channel board, because what it's doing in the background is it's writing directly to that PWM pin, so you can't somehow capture that and stick it through the Adafruit software that then goes on to one of the other boards. There's another servo easing, there's two servo easing things that come up when you search for them. The top two, servo easing and servo easing, very kindly the developers have called them exactly the same things to confuse the hell out of people. But one of them is the one I'm using here, which is very basic. The other one's more complex and does support like the 16 channel servo ones. But it's, you know, I kind of, if you want to amaze your friends and be popular at a party, then I'll do servo easy build stuff and say, hey, that's magic, as you said, for all of us, it's voodoo. Cool. Any more questions on servo easing and that basic stuff before we kind of move on?
How much are servos?
How much, sir?
How much are the servos?
The servos, the SG90s are 15 quid for 5 or something. A couple of quid, it's really cheap.
I've got some, they're not metal, the next one's up.
Yeah.
I can't remember what they're called now, but they're quite expensive.
Yeah, you can. I mean, you can pay a lot of money. You can pay thousands of pounds for servos.
So it's probably about 20 each.
Yeah. Yeah, and this is, you know, I mean, so the stuff that I've done with these, I tend to play in the really cheap area just so that, you know, what's the cheapest way you can get these things working. But there's everything, you know, you get what you pay for. So you kind of ramp up, you get
Like you say,
servos.
you get some cheap ones, it means to start working out what you need.
It's for playing, just to learn, and then
The dear ones, when you've got it sorted.
Well, that's it, you know, you're talking, I don't know, sort of 6-8 quid for an Arduino board. You can buy 2 or 3 of them at the same time with a slight discount. Grab a load of servos. There are Arduino kits, which is, if you go onto Amazon, you get a board and then you get every component. You get one LED switches, servos, like just to kind of let me play with it type thing. But that's what I do. eBay's brilliant. Grab as many of the Chinese components as possible, play with them, learn about it, realise the limitations of it, and then what you start to do is upgrade the hardware to the content Cool. So, nearly done. Last bit really, I guess, is then expanding. The options really are limitless. When I said to you before about, just saying about this servo kit, the Arduino kits, these are the kind of things that you end up with. So you get a shed load of these things at the bottom, which called resistors, don't know what they do something with electric, quite that way. You've got LEDs, transistors, a load of cables, components. So that's a joystick, that's the one that I use on the controller for this one. You've got some digital displays, servos, cables, you know, kind of remotes. You can get water sensors. A lot of people now build irrigation systems that run off Arduino that water your own plants, so that you can go and sand your 3D printed drawings in peace without having to worry about what's happening back to the house. And then these are kind of all of the other sort of components that kick around. You can get Hall sensors, which are magnetic sensors that tell you how close a magnet is. So the limitation is kind of endless. I'm a great fan of James Bruton. I think he's an amazing guy. I'm always watching his YouTube videos because whatever new funky technology and new ideas comes up, he's generally got a bit of play with it and you get the concept basically of what it actually does.
At home I have a Raspberry Pi kit with lots of different things. Would I be able to use that with an Arduino?
The Raspberry Pi kit?
There's lots of different
Yes.
devices and stuff.
The components that you get with the Raspberry Pi kit should work with the Arduino. Connecting, you're obviously cleverer than I am because I don't know how to use Raspberry Pi, but connecting the Raspberry Pi to an Arduino, I'm not quite sure about, but certainly all of the components you get with it should just be transferable. You should be doing this probably. Okay, any more questions? Okay, cool. So, yeah, play around, expand, see what it does. This is just a little bit, I guess, into that future of Arduino. I went to meet this guy, mentally was the CEO of Arduino with work, so I was in my professional mode, which was just shaking hands. And inside I was like, oh my god, this is the Arduino man, and also I was quite cool about it, it was all fine. What they're starting to do now is they're moving heavily into IoT. So because Arduino is an input and output, they can collect so much data and they can start to move that data into the cloud, and they're providing cloud services off the back of that. That's really kind of exciting when you start to think about connecting sensors, taking on some of the things that we do, collecting information, sticking it somewhere and doing it with things, doing things with it, and connecting things to Wi-Fi and all sorts of stuff. So they've got quite an ambitious kind of development going forward, but their plan is always to create electronics that automate at a really kind of low cost. And that's pretty much it, unless we've got any further questions.
Not a question as such, but a problem with the new version of Arduino and the IDE. You have to change better to legacy bootloader you can work with the Arduino.
Yeah, I think they're changing to bootloaders are on for the genuine Arduino. If you're using clones that use the CH40 driver, you have to use old bootloaders.
You also have 1.8.9 version will work, which is changed to legacy bootloader.
Okay.
I was tinkering yesterday morning.
Probably my problem then.
You don't find it because you've got genuine Arduinos. You buy cheap knockoff, yeah.
I've got this Mega at the moment and it's, because when they did the instructions list, they look you have to wire the RX to the RX and the TX to the TX for it to actually work. Whereas on all the other ones, it works on TX to RX and RX to TX, so I'm quite sure it's some dodgy clone and I thought this isn't quite right. I need to read just all the instructions so that those people are not being able to get these damn things working because I've got some cheap Chinese knockoff guns. Apologies for that, folks. Okay, thank you very much.